let's look at selecting the first BFS. Change things, okay? And this, I'm doing it first because it's kind of a neat idea. Okay, I really like, again, the way they solve this problem, right? So, you can always assume that your program is in this form, right? Actually, do you remember how did we find the BFS in the first BFS in the simple example we did last time? We were lucky, right? So we can assume this is the standard form. Now we put slack variables so that these become typed. So then max and now if B was entry wise positive, done. That is my basic feasible solution. I will just take all the slack variables, number of slack variables equal to m, happy. Problem is, what if some of them are negative? Okay. So then, what I need to do now is this trick. Of surplus variables. Okay. So what this does is AX minus XS, this is the surplus variables, right? So assume the other slack variables, they took care of the remaining ones. Now surplus variables, x greater than equal to 0, right? But then ultimately, what do I want? Ultimately, I want these surpluses to become 0, right? So then, whatever were my, and this is kind of a nice change. So what do I now need to see is, if my initial thing was feasible, right, then there is a solution here where all excesses are 0. And if I get a solution here, that can make me go here. Okay. So now, but the good thing about this is that I have a BFS. I have a BFS to start.
How do we exactly define surplus?
Oh, simply put, wherever my B was negative in those equations, I will put an extra variable. So I will take an example. Obviously a small example because this is going to take some time, but yeah, okay, let me take an example and then you can tell me if things are clear to you. Suppose this is the LP I wanted to solve. Correct? Then this is good. This is my slack variable. This is nice. Here I am introducing this extra variable which allows to absorb, for whatever solution, if it was greater than -2, still I can come up with a solution by keeping x5, right? So if x1 minus 2x2 was 0, I can still make that 2 and have that out here, right? So it is not clear that a solution here is the solution of my original thing, right? This is not true. I don't want that. What I do now is, so instead of this, I want to say that I want to maximize, minimize some of that, one of that. Or minimize, you want to say, did I have more variables? So oh sorry, I did a mistake, sorry. Yeah. First, yeah, -2, okay, so this is all the slack variables, and then I add -xx. Okay. So and then I have to have all these things, right? x1, x2. Right? So x6 is allowing me to make up a solution, but the problem here is that if x6 is positive or negative, then I'm in deep trouble, right? So ultimately, finally, I want to make x6 0, right? So when x6 is 0, then a solution here is a good solution here, correct? So since I want x6 to be 0, I am maximizing -x6. Remember, x6 is greater than equal to 0. Since it is greater than equal to 0, this maximum is at most 0. Right? So this is the target. This is how I change it. So what you want to convince yourself now is that, okay, if there is a feasible solution here, I can take that feasible solution, I can add x6 equal to 0. It will remain a feasible solution, it is 0. Great. And there can be multiple surplus variables here. Just a second, Anushka. There can be multiple surplus variables, 3, 4 equations, xx plus x7 plus x8. But if that maximization turns out to be 0, that means all those surplus variables are 0. Right? So if this is feasible, this has a solution at 0. And if this has a solution at 0, I can actually get my BFS here. Because what I will be doing was I will be going through BFSs here, correct? I will go through BFSs here. Finally, at the optimal one, I will know that all my surplus variables are 0. The remaining thing will become my basic feasible solution. That's the nice idea. Surplus variable. Yeah, this is in which wherever my B was negative. No. So see, the problem was that if I did not have x6, I would try to have my basic feasible solution as x4, x5. But then x5 is equal to -2. That's not a feasible solution. So what I do is I put a -x6 surplus variable. Now I have a basic solution. What is my basic solution? Sorry. So this trick has allowed me to find a basic feasible solution to start with. But then I also wanted to make sure that this becomes 0, so I changed the objective function. So this is probably the thing. Yes.
The direction of increase of objective function is because you lost the information minus 2x1 minus 3x2.
I'm not worried about any optimal of this linear program. The entire objective of this LP is to find whether original LP is feasible or not. If yes, give a BFS. This is the reason why I have invented this LP. And since this is the reason, objective function is redundant. If I want to just do this, I can throw this in the sink and forget all about it. That's what I have done. Questions? So I think this is a nice trick, right? Just by applying this surplus variable and this smartly changing the maximization, you have changed the problem. Yeah, so you can call them surplus, auxiliary, whatever is, yeah, I think probably I called them auxiliary in the notes, right? But, so, yeah, I will save some time. Now, these are my basic variables, right? So that means I want to write x4 equal to in terms of non-basic, xx equal to in terms of non-basic, and this optimization function. Now I have forgotten all about this. I'm just worried about this. Right? So then, sorry. And now, for at least for this LP, you look at this, obviously I want it to make a 0. So that means x2 is my entering variable. Which is my leaving variable? Sorry? x6, because this is positive. So there is no problem here. This is the one. So that means I can change it to, now x2 will become 1. I will figure that out. Okay. So my, this is my new BFS. And if you change according to this, so what will I do? I will substitute. So x2 in terms of x6. x2 in terms of x6 is 2 plus x1 minus x6 plus x5 divided by 2. Okay, and at least you can see that when I put this here, this minus 2 gets cancelled. Okay, so I get sorry? Oh,
If you back to
0.
x is again
Right, right. Or you are saying that this objective function has to match that objective function. Then it has to be x6. Okay. Actually, why am I writing this? Yeah. Right? So now I have a basic feasible solution to start for this. Sorry. Now I get back to this LP, x2 equal to 1 and x4 equal to 6. Okay, now I can write x4 in terms of non-basic, okay, and then change, and you can write everything in terms of x2 and x4. And that is possible because you know that the columns of x2 and columns of x4 are going to be invertible. Okay, so there is a small thing here. So what do I want to show? The final BFS I am going to see is going to give me a BFS of the original program. Right? Why is that? What is the proof? You saw the problem? What I want to now show is the BFS. I will get a BFS here. What I know is that my optimal value is 0. Right? I have reached that value. Now what I'm saying is that BFS should give me a BFS to start with in my original LP. Right, but what is my BFS? There is a BFS here. There are some variables. How do you transfer them to some variables there? It's exactly the same. What if there are some surplus variables here in the... Exactly. So now if you look at the basic feasible set here, it will have some non-surplus variables, non-auxiliary variables, some normal variables. Just keep those normal variables. You know rest of them are 0. Whatever are remaining, the columns are linearly independent. Because the entire thing was linearly independent, this is linearly independent. Now, if they are not M, you can add some extra columns to make them M. All this trick I have done the second time, right? You have some linearly independent columns, but they are not making up the rank of M. How do you convert them into a basic feasible solution? There has to be some few columns here which will make the rank M, right? That is by the property linear algebra, right? So just pick whatever columns you need to make these linearly independent. And so it is okay for your basic variables to be 0. Non-basic cannot be non-zero. Okay, and this is the reason of degeneracy, right? This is when degeneracy happens, when your basic variables are 0 and they circulate among them. Clear? So this is how we take care of starting with the basic feasible solution. Okay, this trick of having a new objective function solving an entirely new LP.